My name is Kundan Sarma. Today I am here to do numericals on chapter 7 work energy, and this is for my physics 221 class. The question is, a package of spicy Cajun pralines lies on a frictionless floor attached to a free end of a spring. So this is the spring, this is the package, and it is attached over here. So the question is, and it also says that a 4.9 Newton force is applied in a right direction such that the spring stretches 12 millimeters. So we are asked to find how much does the spring force do on the package if the package is pulled rightward from x0 0 millimeters to x2 17 millimeters. So here we are given a force of 4.9 Newton. Extension caused by this force is 12 millimeters. So let's say spring constant to be K. Let's take the right direction to be negative and left direction to be positive. So since it is the force that is pulled, spring constant would be force over extension, and we take this force to be negative, and it would be negative of, since the force is applied on the right direction, it's negative of negative 4.9 divided by 12 into 10 to the power minus 3, and that would be 408 Newton per meter. So after we get the spring constant, we can calculate the work done by the spring as the potential energy stored in the spring. So that would be W of S would be minus half k x square, and since we want to find the energy stored in spring at 17 millimeters, it would be minus half value of k we just got from here, 408, and 17 into 10 to the power minus 3 whole square. So we get the value to be 0.059 joules. So this is the total work that the spring does on the package if the package is pulled rightward from 0 to 15 millimeters. And the second question is, the package is now moved leftward to x3 equals to minus 12 millimeters. So how much work does the spring force do on the package during this displacement? So here the x1 is plus 17 millimeters, that is plus shows the length of the length of the spring that has been stressed, and the negative sign shows the length of the spring that has been compressed. So when initially the package was at the position of plus 17 millimeters at the position when the spring was stressed 17 millimeters. So now the package is at the point where the spring is now compressed minus 12 millimeters. So we need to find the work the spring force do on the package. So we can find the total work done by the spring force on the package when when it is stressed from 17 millimeters and to the point where it is compressed to minus 12 millimeters, by subtracting the initial potential energy of the spring minus the final potential energy of the spring. So the initial potential energy of the spring would be half k x1 square minus the final potential energy of the spring would be half k xf square. So taking care half k to be common, we get this to be half k xi square minus xf square. So half value of k would be 408, and since we know initially the spring was stretched 17 millimeters, so initial xi would be 17 into 10 to the power minus 3 meters minus, and we know the spring was compressed 12 millimeters, so it would be minus 12 10 to the power minus 3 meters. So since this is work done, everything would be in joules. So it would be 0.030 joules, that is 30 millijoules. Therefore, the work the spring force does on the package during the displacement from plus 17 millimeters to minus 12 millimeters would be 30 millijoules. Thank you.